Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Today's topic is Matter in Our Surroundings, Class 9, Chapter 1. What is matter? Everything around us like air, water, stone, sand, cloud, pencil, book, etc. is made up of matter. So matter is anything that has a mass and occupies space. Early Indian philosopher classified matter into 5 basic elements, the Panch Tattva: air, earth, fire, sky and water. According to them, living as well as non-living things are made up of these elements. Physical nature of matter. Is matter continuous or particulate? Matter is a particulate in nature. This means that the matter consists of particles, as you can see in the microscopic image of the cube. For example, if you put a drop of red color in water, the color of water turns red. This happens because the particles of red color mix with the particles of water. What is the size of these particles? The size of these particles of matter are very small and they can be broken into further particles as well. For example, if we take one crystal of potassium permanganate and dissolve it into 100 ml of water, the color of solution will be dark pink. On diluting this solution several times, we can see the color of the solution will become lighter and lighter, but the color is still visible. This means that there are millions of particles present in the color which just divide themselves on dilution. This shows that the size of the particle is extremely small. Characters of particles of matter. Particles of matter have 3 characteristics. First is particles of matter have space between them. Sugar gets dissolved in water because its particle has space between them. If we dissolve 50 grams of sugar in 100 ml of water, the sugar particle will go into the spaces between various molecules of water, due to which there is no change in the volume of sugar solution. Second characteristic is particles of matter are constantly moving. Particles of matter are in motion all the time, hence they possess kinetic energy, and this property can be explained by diffusion. Diffusion. Intermixing of particles of 2 different types of matter on their own is called diffusion. It is a phenomenon in which the movement of molecules or particles occur from higher concentration to the lower concentration. For example, when a perfume bottle is opened in one corner of the room, its fragrance spread in the whole room. This is because the particles of perfume move rapidly in all directions and mix with the moving particles of air in the room. Third characteristic is particles of matter attract each other. Force of attraction between particles of matter keeps the particle bonded together. The force of attraction between the particles of solid is greatest, in liquid it's moderate, and in gas it's lowest. That is why we can move our hand through the air easily. In liquid we have to apply some force to move our hand, and in solid we cannot move our hand. States of matter. There are 3 states of matter: solid, liquid and gas. You can see the molecular structure of solid, liquid and gas here. Solid is compact, liquid have some space and gases have very large spaces between their molecules. Solid, difference between solid, liquid and gas. Solids have a definite shape, liquids have indefinite shape and gases also have indefinite shape. Solids have definite volume, Liquid also have definite volume, but gas has indefinite volume. Force of attraction is maximum in solid, moderate in liquids, and minimum in gas. Kinetic energy of the particle is minimum in solids, moderate in liquid, and maximum in gases. Compression. Solids cannot be compressed, liquid cannot be compressed, but gases can be compressed. Density. Solids have highest density, liquid has lower density, and gas have lowest density. Interparticle spaces is very small between the molecules of solid, comparatively larger than solids in liquid, and very large spaces between the molecules in gases. Diffusion is negligible in solid, slow in liquid, and very fast in gases. The 5 states of matter. By far, we have discussed that there are 3 states of matter: solid, liquid, and gases, but scientists also discovered that there are 2 more states of matter. These are: the 4th state is plasma, and the 5th state is Bose-Einstein condensate. Plasma. It is the state of matter in which the particles are super excited and super energetic. They are in the form of ionized gases. For example, fluorescent tubes and neon light bulbs consist of plasma. The neon bulbs contain neon gas and another gas such as helium in the fluorescent tube. As electricity is passed in the tube or the bulb, these gases get ionized and creates a plasma inside them that glows. The sun and the star glow because plasma is present in them. Here are some examples of plasma: stars, lightning, neon light, plasma TV, etc. Bose-Einstein condensate. It is the 5th state of matter discovered by Albert Einstein based on the studies conducted by an Indian scientist, Satyanarayan Nath Bose. BEC is formed by the condensing gases of extremely low density to much lower temperature. Change of state of matter. The phenomena of change from one state of matter to another and then back to its original state is called interconversion of states of matter. Matter can change its state. Water can exist in 3 states of matter. In solid state, it is ice. In liquid state, it's called water. And in gas state, it's called water vapors. The various states of matter can be interchanged into one another by altering the conditions of temperature or pressure. Effect of change of temperature. What happens when we increase the temperature? In solids, on increasing the temperature of solid, the kinetic energy of the particle increases. Due to increase in kinetic energy, particle starts vibrating with greater speed and energy supplied over the time. Force of attraction of the particles, and then the particles leave fixed position and start moving freely, and the solid melts into liquid. Melting or fusion. The process due to which solid changes into liquid state by absorbing heat energy is called melting or fusion. So solid changes into liquid by the process of melting. Melting point. The constant temperature at which a solid changes into liquid is known as its melting point. The melting point of ice is 273.16 Kelvin. Freezing or solidification. The opposite of melting is freezing. That means the process of liquid changing into solid state by giving out heat energy is called freezing. Freezing point. The constant temperature at which liquid changes into solid state is called the freezing point. Numerical value of freezing point and melting point is same. That is, melting point of ice is equal to freezing point of water. That is 0 degree or 273.16 kelvins. In the melting process, once the solid reaches its melting point, its temperature does not increase further. So where does all the heat go? The heat present in the solid at the time of melting is used by the particles to diminish the force of attraction between each other. The heat energy is therefore considered hidden. Latent heat. The heat used to break the force of attraction between the particles of matter is known as latent heat. Since heat is hidden in the bulk of matter, therefore it is called latent heat. Latent heat of fusion. The amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Atmospheric pressure is the pressure exerted by the weight of the atmosphere. In liquids. Just like solid, when the heat is given to liquid, the kinetic energy of the particles of liquid start increasing. So the force of attraction among them starts decreasing and they start moving freely, and a point comes where the particle overcome the force of attraction completely, and this is when the liquid starts changing into gas. Boiling point. The temperature at which the liquid starts boiling at the atmospheric pressure is known as boiling point. For example, boiling point of water is 373 Kelvin. Latent heat of vaporization. The amount of heat required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is known as latent heat of vaporization. What happens when we decrease the temperature? In gases, when we decrease the temperature of the gases, the kinetic energy between the particles of the gas decrease and the force of attraction increases, and then they turn into liquid state. Condensation. The process of converting gas into liquid by decreasing its temperature is called condensation. Example is the formation of cloud due to condensation of water vapor from the earth. Sublimation. The change of state of gas directly into solid and vice versa is known as sublimation. For example, camphor is a solid that directly evaporates in air without changing into liquid state. Effect of change of pressure. By applying pressure, we can bring the particles of matter close to each other, thereby increasing the force of attraction among the particles. When we compress and decrease the temperature of the gas changes into liquid. Dry ice. Carbon dioxide in the form of solid is known as dry ice. It can directly turn into gas by decreasing the pressure to 1 atmosphere. Evaporation. The phenomena of change of liquid into gas at any given temperature below its boiling point is called evaporation. Evaporation is different from boiling. As shown here, you can see in evaporation, vapor pressure is less than atmospheric pressure, so bubbles cannot form. But in boiling, vapor pressure is equal to atmospheric pressure and bubbles can form. Change of state of matter. So you can see the solid through the process of melting changes into liquid, and again through the process of freezing, liquid changes into solid. Similarly, liquid changes into gas through the process of evaporation, and gas again changes into liquid through the process of condensation. Similarly, solid changes into gases and vice versa directly through sublimation process. Can also be known as deposition. Factors affecting evaporation. condition, if there is increase in the surface area, rate of evaporation increases because the particles have more space and thus can evaporate easily. If there is increase in temperature, then the rate of evaporation also increases because kinetic energy among the particles increases. If there is increase in the humidity, then rate of evaporation decreases because water content in air increases and so evaporation decreases. If there is increase in the wind speed, then the rate of evaporation increases because water vapors are blown away by wind, allowing more evaporation. How evaporation causes cooling? The process of evaporation uses the energy of liquid particles. Therefore, the particle absorb energy from the surrounding in order to compensate for the energy that is being lost in the process of evaporation. This results in the cooling of the surrounding area. As you can see here, the high energy particles are evaporating, medium energy particles pulled back into the water, and low energy particles remain in the liquid. For example, our palms feel cool when you put some acetone or the nail paint remover on it. People sprinkle water on the roof or ground on sunny days to cool the air. We are able to sip hot tea faster in saucer than in a cup. Why does people wear cotton clothes in the summer? We sweat more in summers. As the sweat evaporates, it takes energy from our body surface and keeps our body cool. Cotton can absorb the sweat easily and expose it to the atmosphere, causing evaporation to take place easily. This in turn keeps us cool on summer days. Why do water droplets appear in the surrounding of a glass with ice cold water? There are water vapors present in air. When they come in contact with the walls of the glass that has ice cold water in it, they condense. As a result, their state changes from gas state to liquid state, thus forming tiny water droplets on the walls of the glass. Important measurement units. You can see the chart of some of the important measurement unit. You can pause the video to take a look on it. Thanks for watching. Please do like, share and subscribe.